what is accessible, or kind of how much trouble you can be in. So it just definitely gives us a different way to present this product as we had before. But Gus is going to share with you what XM Cyber is all about, which from the R2 perspective, it's really about taking a massive amount of vulnerabilities and turning them into actionable events, right? So instead of saying you've got 7 or 10,000 vulnerabilities in your environment to patch between now and Sunday, it's going to tell you, I like to use Jason. Jason's on the line, so I like to use Jason. It's going to be, hey, Jason's laptop is the most likely one to be compromised because he failed his phishing exams, and if he's compromised, what data can we get to, and how do we get that, right? So Gus is going to share with you how XM Cyber has revolutionized that attack path scenario versus the traditional vulnerability management tool, which is taking inventory. It's basically saying, what are you susceptible to? So with that being said, if you got any questions, again, you can pop them in the chat or pop them in the WebEx Q&A section, or you just shout them right out. So I'm introducing Gus.
Thank you, Jamie, and thank you everyone for joining today. So I'm the Director of Field Engineering here at XM Cyber. So I do work with pre-sales and post-sales with customers. A lot of the work that I do is a lot of the implementation, helping customers harden their environments and things like that on the post side. Now, the one thing we want to talk about today is what attack paths have you created today? And that question goes out to everyone here on the call today. Just think about, what potential changes have happened in your environment today, and what attack paths have they created? Not to use SolarWinds, but that was obviously a 8-month attack path, or however long they've been infiltrated. But you just simply don't know what changes are happening, right? That could have just simply happened from a product update. There's a backdoor, and now there's a path. But we want to just really understand, if I do a network change, an RDP session, a security group, and think about what the consequences of that are to critical assets. That could be anything from your data center, could be a SQL database, could be your CEO's laptop. And on the other hand, also think about, you might be doing the right thing, you might be changing something, but your counterpart might want to allow a specific user to do things easier and adding them as an admin, right? So there's also other people in the mix, and understanding again what paths are created based on all these changes is what we want to focus on today. As an example, we can use ransomware. So in the headlines, we see ransomware all the time. There's a lot of focus on talking about the payload. Oftentimes that's, the APT group who tend to talk about the behaviors, but the payload is always like, what's in the news. But the problems often start way beforehand, right? There's a lot of attackers that can be in an environment for a long period of time. They could be in and out very quickly, but it really all depends on what your environment looks like. What opportunities does the attacker have once they're in your network to actually go through this entire kill chain? Are they going to be able to find an easy vulnerability with just a simple scanner to get in, right? Or, are they going to be lucky enough to land on a box where they have an admin account that they can harvest, or are they only going to find a user account where they're going to have a more difficult time potentially moving around? So the whole point here is to really understand what are these problems before the payload occurs, and how can we stop this full kill chain with, again, using IT hygiene, vulnerability management, user activities, and just simply identifying them and then prioritizing how to fix it. The other part is the cloud. So a lot of customers obviously have cloud environments, not just cloud, not just on-prem. There could be a combination of both. A lot of attackers are pivoting from on-prem environments to the cloud. It doesn't necessarily mean that your cloud instance needs to be attacked directly. If an attacker is lucky enough and lands on a developer's laptop or an IT laptop that has an AWS or Azure access token, they can pivot, right? That's basically how it can happen. Or if you have public-facing EC2s or VMs where there's a web service, that could potentially be the entry point in, and then from that point on, whatever configurations they can use for privilege escalation, they will. The whole point here, though, is that it adds to the complexity. First, you had on-prem environments, you have VPN, you have different network configurations, system software. Now you add more to the mix with the cloud. And ultimately, you have complexity being a vulnerability in itself. Simply understanding how everything interconnects. It's human to make mistakes and things happen, The problem is, how do you identify when they cause a serious issue? In typical breaches, the things that you'll find are misconfigurations or bad hygiene, right? Again, using one account, for instance, to do everything in your environment, including browsing the internet on your laptop. It could be anything from not having UAC on. Also vulnerabilities. How do you prioritize your vulnerabilities? What are you closing the gaps on from a vulnerability perspective? But the problem also comes down to, how do I prioritize? Is it good enough that I'm just focusing all my attention on my servers right away? Is the attacker going to be deterred if my servers are patched? Well, that's not typically the case, right? They find other ways to pivot. And then the last part is user behavior. Many cases, you need the users to do something in order for the attacker to do something. So that's part of the cycle of a breach. You're going to find these in any one of them. Now, the Verizon breach report tracks these metrics, and they identify, how the attackers are evolving, what attacks are being used in different breaches. So as you can see here on the left-hand side, in 2015, where we had the malware problem, obviously a lot of EDRs and AV and machine learning have kind of stopped that. But on the other hand, if you look at 2020, phishing is the biggest problem, right? That's how they're getting into the environment. Use of stolen credentials. Credentials, the number one attack technique in an environment. So again, it's just simple IT hygiene things like misconfigurations, phishing, stolen credentials that are causing the breaches. Part of this challenge is prioritization, right? If you can't prioritize and focus on what you need to fix, then you're going to miss things that an attacker can leverage. And a lot of companies are having an issue with that, especially when it comes to vulnerability management. And the other part is visibility. Right? How do you know if the successful logon is, yourself getting to the server, or if an attacker actually has those credentials and is doing the logins themselves, right? How can you differentiate that? When you don't really have visibility into, what can happen in your environment, it's hard to protect it. So the question I want to ask is, how short is the attack path today? How simple is it for your environments to simply point to a computer, a server, or an S3 bucket and say, show me how an attacker would get there? Is it going to take 2 steps, 10 steps, 5 steps? How do I know how they will move around? Because if I don't know that, then obviously I can't fix it. Okay, seems to be some background noise there. So again, the common thing here is credential theft, social attacks, and errors. And what the Verizon breach report basically is showing here is that 95% of incidents and breaches occur in either 5 steps or less. So the goal here is not to always try to eliminate the risk, right? You got to do what you can to eliminate it, but also don't give up if you can't. Just make it a little bit more difficult for the attacker to maneuver. The more difficult you make it, the more attackers you will deter, because it's not simply come in, run Mimikatz, get a credential, and then just cause mayhem. If they can't get a credential, they're going to have to work harder. And, if they're trying to go in and out, they're not going to want to do that. The whole point here is that they might be deterred and go somewhere else. Now, what we are focused on here in XM Cyber is asking 3 questions to simply find those answers. Well, the first one is, are my critical assets secure? How can we help customers identify what those steps are, what capabilities your environment would give to an attacker, and doing that all the time. The other part is prioritization. We obviously find these problems. The next thing is, how do you fix them? What can we produce as an output to help you prioritize your team's efforts and not, having them play whack-a-mole, basically, right? And then the last part is validation. How do we know we fixed it correctly? If we fix something today, how do we not know it? How do we know that it doesn't come back tomorrow? If I make a change, maybe someone else goes and says, well, who did this change? I should change it back. And then the risk is back, right? If you think about pen testing, where you have a yearly report, there's an entire gap of 365 days in between that report, right? If you fix something today, are you sure it's not going to come back a month from now, a week from now, whatever it might be? So those are the 3 things that we're focused on. One of the ways that we're finding these issues is by targeting on what matters most, what's causing the most risk in our environment. And it's not all vulnerabilities, which you'll get in a very large report. It's not, again, specific vulnerabilities where you have info and medium, high severity, right? Getting a long list of vulnerabilities is not going to help you find that. what we do is start to focus on what the attackers are looking for. Well, they're looking for user activity, right? RDP sessions, SSH sessions, specific user browsing, things like that. That's going to help them get into the network or move around. The other part is misconfigurations. What would allow the attacker, again, in your environment, to abuse something in order to move laterally? How can they get more and more? And then lastly, we focus on exploitable vulnerabilities, right? Which ones of the vulnerabilities that are out there are being used by attackers so that we can help you prioritize. And when you put these three things together, what we're able to find is the riskiest assets that would cause a breach in your environment or an incident or overall the most risk, right? Helping you focus instead of 7,000 problems down to 13.
Yeah, I just
One,
want to specify
yeah,
where vulnerabilities come from, right? I mean, there's two types of vulnerabilities in, I guess, any software, right? When someone consciously discloses a vulnerability to Microsoft, in some cases, those are actual vulnerabilities that they have found in the wild, right? Someone's been attacked with that vulnerability, but many times that vulnerability exists in a lab, right? There's a lot of things that we know that we have patched or we've prepared for that there's actually no known exploits for. So when you start upper left-hand corner and talk about 140,000 vulnerabilities in a vulnerability database, XM Cyber's job is to kind of whittle that down and say, okay, what's realistic, right? What's in the wild? What do we actually see people being attacked with? So it takes away a lot of that otherwise like shotgun style work where you're just applying every fix all the time. And that's how we're kind of getting into the meat of it.
yeah, great point there, Jamie. The other part that we're focused on, just to go on what Jamie was talking about, is oftentimes vulnerabilities are scanned and identifying risk on critical assets. For instance, I have a patch and remediation. Should I prioritize patching my servers or should I fix my laptops also? If you're focused on the risk on device, obviously you'd probably want to fix your servers first, right? They have the data, they have the critical things on them that you want to protect those servers first and not make it easy for someone to get there. But if you neglect everything around that server, for instance, of how an attacker can pivot, they're not going to be deterred just because simply your server is patched, right? So we want to always look for the risk to critical assets, which is, just because you patched your server doesn't necessarily mean we can't compromise this other laptop and, you logged into it with an administrator account, and now we can actually harvest that and use it to get to the server, right? So it doesn't take much if you're not focused around the entire ecosystem. Some of that equation looks like this. For risk-based vulnerability management solutions, it's you have the severity, the threat intelligence, the asset criticality, and based on that information, the system might tell you, go and patch server number 2. But again, we want to focus on adding another question is, can any other device or entity in the environment be used to actually get to server number 2? And if the answer is yes, just as a very basic, simple example here, if we can use PC4 because it's also not patched to get to server 2, our output would not simply be go patch server 2, it would be go also patch and fix PC number 4, right? Or if PC4 gave us some credentials or things like that. The whole point is to always look at the surrounding issues. What ultimately you'll be able to do with the solution is ask questions. How can my customer database be compromised? At a small scale, you'll get something like this, right? You'll see that we start a attack from an HR computer. We can move into another device, get to another subnet, get an RDP session, and ultimately get to the database. The point here is that we use those misconfigurations, activities, and vulnerabilities to show you these paths as they're created on a daily basis. And the other part is the solution is automated, meaning you do not need to come up with any type of attack techniques or anything like that. You simply need to just point to what asset you want the risk to, and we will find a path there. That gives the added benefit of it being a repeatable process and reproducible because it's not based on human knowledge. It's based off of pure data. So if your environment looks the same every single day, you're going to get the same result every single day unless there's a new attack vector or something along those lines, and it can be used. But on the other hand, if it changes day to day, again, it's going to be based off of pure information we're getting from the environment, and those pathways change every single day. Okay. The last part here, we also have integrations that we're working on. One of the integrations we do is with endpoint security vendors, and we're helping enrich the information for them. One way it's helping SOC teams is by prioritizing what they need to work on off their EDR events. If they see that they have 10 devices, for instance, with a Mimikatz alert on their EDR, you might want to say, well, which device do I work on? When you have XM Cyber enriching that information and vice versa, we can actually tell you, well, one of those devices gets us to your customer database. So from the EDR portal, you can say, hey, I have 10 computers with Mimikatz, but one of them actually gets the attacker to a database. Let's focus on that and remediate that first, isolate it, because the likelihood of the attacker getting to that database from that machine is a lot higher. Okay. So at the end, what we produce is a risk assessment with multi-attack vector paths. We validate making sure things are possible in your environment, and it's completely automated. The other part is providing you remediations with multiple attack vectors, not just simply giving you vulnerabilities or Active Directory reports or anything like that. We're literally looking at it from an attacker's perspective. And the last part is a continuous risk validation, making sure that things change on a daily basis. Let's make sure we're aware of what those changes mean to our critical assets. And the last part here is just an article from Gartner that simply says that we should be able to prevent what we can and detect and respond to what remains. The whole point here is that there's a lot of things that we can do before just depending on our security controls, like an EDR solution or an IDS to detect these bad behaviors that might be happening in the environment or anomalies. There's a lot of things that we can do in our IT hygiene perspective to strengthen our environment, use least privilege models and things like that, that would really make it harder for the attacker to move around, right? So we don't just simply rely on, the latest and greatest EDR behavior rules. Okay, any questions or anything else before we jump into the demo here? Or anything you want to add, Jamie?
No, we're good. I mean,
All
I do want to touch on red team, blue team about what that means for the environment. If you want to give a summary of why you guys brand yourself as that kind of red team, automated red team, blue team.
Absolutely. Well, the first thing as a red team is to find, what we're trying to get to, right? It actually segues pretty well here because what you're seeing right now is the battleground view for us, and everything starts with scenarios. So if you think about a red team coming in and doing an assessment, they're going to have a goal in mind, right? A red team is not going to come in and say, okay, well, let me just see how we can destroy everything. That's not the point. You might have some sensitive information. You might have a data center. You might have something that you care about that you want the red team to assess the risk to. And that's the way we operate. We operate on exactly the same model, which is creating scenarios. What would you want us to try to get to or compromise in the environment? So when you create these scenarios, and you can create multiple ones, the whole point here is to try to target your critical assets so you can clearly identify the risk to them, okay? Here we have an example called hybrid risk to AWS and S3 and customer database. The whole point here is that we want to assess the risk from a specific location and try to target two of our crown jewels. So the red team exercise would simply be, hey, Mr. Virtual red teamer, I want you to see how you'd be able to get from this partner portal that's exposed to the internet, but my sales teams also interact with it, and see if you can get to my crown jewels. So what you'll ask it is, I'm pretty sure I have done everything I can. I've excluded it from my internal network. It's in the DMZ. I've put my firewall rules in place, but see if you can get to my crown jewel. So you tell the system, start from this partner portal. The next thing is, what are we trying to target? Well, I want you to try to get to my S3 bucket that has my finance database. Again, this is in the cloud. And the other part is, I want you to get to my customer database that's sitting on a Linux server in my data center. So those are your goals, okay? It's not everything in here. I just want to know, can you get to those two critical assets from that specific portal? When you push play, the system will try to find these paths. Now, again, going back to the presentation, it's not just a once-a-time test. So this is running continuously in your environment, collecting information. So if we can't get there in an hour, in 2 hours, in a day or a week, it all depends on what your environment configurations look like. And again, if there's any new threats. So you will not be able to, you'll basically not miss the risk calculation here because it runs every single day, not once a month. And so any of these changes that are happening will be incorporated into finding and answering that question, is there a way to get there? Okay. And in many environments, depending on the scenarios that we set up, we have a lot of customers that do like subnet to subnet testing. Basically, here's subnet number one. I don't expect you to get subnet number two. And maybe for 4 or 5 days, we can't get into it. But it just takes one RDP session or maybe a once a month firewall change to do some update that will allow that communication. And then we can see that occurring, right? And present that information to the customers.
So one
Now,
question we got regularly in the first two sessions was, as customers were watching this, they were trying to assess what they would do in I guess a normal environment where they did a pen test, right? And most of our customers during a pen test, they will just ratchet up those firewalls real tight, right? They'll pull all very restrictive policies because let's face it, they want to pass that pen test. So this product is really designed around operations. So it's designed around not having to create some sort of false security for yourself. It's saying, hey, if you feel like you're well protected, or if you just want to have that awareness, right? Not, hey, I want a piece of paper from somebody, but I want the awareness of, am I going to have a really bad day at the office that involves a ransomware attack? We want you to run and operate this product, and this product will run and operate under regular, normal operational circumstances, regular firewall rules, regular policies in your EDR tools, things like that. So this constantly is testing your existing IT ops policy.
Yep, that's a good point. Yeah, I mean, the solution is architected to run in production. I mean, we run on thousands of systems within environments. And the whole point there is just because it could take one simple login. And to give you a primary example, I had a customer where, they used the wrong account that was supposed to be only for domain controller deployments to the rest of their environment. And they had that credential sitting, on 3,000 devices as a domain admin, right? So their risk was through the roof at that one point when someone did that mistake. Now here we have at the end of the simulation, and you don't have to wait till the end to see those results, you can watch it as it goes. You have gray, blue, and red icons. The gray means that we cannot even discover, it's pretty much invisible. The blue means that we can recon or discover, and the red means that we can compromise. But again, the thing here is we don't want you to come in here and look at all these red dots and say I have all these different problems. You need to go back to the question that you ask in the specific scenario, which was, is there a way to get from that partner portal to two crown jewels, the S3 bucket and the customer database? So the focus here is, did those diamonds, which represent the crown jewels, turn red? When you see the crown jewels turn red, that means that we've answered your question, right? And we found a way there. If you see it blue, obviously we can tell you we can recon it. Or if you see it all gray, it means we cannot get there, right? But the point here is that we did find a way to get there. So the next is, how did you do that? What would allow the attacker to get to that database? On the left-hand side, you'll see the step-by-step of how this attack would play out. The first thing we're telling you is that that partner portal, because it's exposed to the internet, could be set up as a watering hole, right? At any point, maybe an attacker find a way to get there. But the main reason we're pointing that out is because we're seeing a user browse to that partner portal from the sales team and doing so with a vulnerable IE browser. Now, going back to risk-based vulnerability management, the equation typically that's used in risk-based vulnerability management solutions would probably tell you not to focus on this laptop and this vulnerability first, right? You'd probably target your servers and other things. One of the challenges that those products have is that they don't have the context around the entire environment and how it can all play out together. Meaning we're doing a lot of legwork to point out that the browsing, the vulnerability, where you're starting the attack from, what we can put together moving forward, it all creates a chain of attack to a critical asset. So the importance here is having context in order to understand what type of risk this would present, right? It's not simply saying it's a server, go patch it. This presents the risk of entry. So once we're on Olivia's computer, because of these, user behaviors and then a vulnerability, the next thing is, well, what else can we get from Olivia's computer to move laterally, right? Just like an attacker would. And here we see that Olivia has the built-in administrator account, like many companies do when they're imaging computers, same passwords. And we're telling you that we can use it for local credentials as lateral movement. So here, the first thing we're telling you is we think we can get from Olivia's computer to Steve's computer. So let's confirm it. The way to do that is to first make sure that there's network communication between Olivia and Steve. So the system asks Olivia, please do a TCP handshake to Steve to make sure we have no firewall in between. If a firewall was there, we would not be able to show you this attack. The next thing is make sure that both of these systems have the built-in administrator account enabled. And on the other hand, they also need to have the same password, right? When an attacker finds the built-in admin account on one system, the password has to be the same on the other as well. The other part is also adding additional conditions. We don't want to just simply assume that, okay, it's the same password, we have network connectivity, this can happen. There's other controls that can stop this, like UAC. Right? Is UAC enabled or not? If it's not, then this would allow it to happen. Is there deny network logon for local accounts? So there's other conditions that we put into place to make sure that this is actually a possibility. Now, once we get onto Steve's computer, we see that he initiates an RDP connection. The whole point of the product here is to help you identify the risk paths and also to help you with policies. I have customers that use jump boxes for RDP, and they're not supposed to be initiated from IT admin laptops. Who is actually looking at that, right? What prevents an IT person from enabling that if he has admin rights on his box? The whole point here is that we can actually map that out. And even if this RDP session happens once a month to get to a data center, our whole purpose is to find that happening and show you how it can be used by an attacker, because an attacker can't do anything until you actually initiate the RDP connection to harvest those credentials, okay? And the last step here is we get into that database with a known Oracle database password. And just to bring it all back, the initial question here was, can we get from that partner portal to the database? We answered yes, and then we showed you every single step of the way of how that's feasible. Okay. Now that's on the on-prem side. The other question we had was also, can you get to an S3 bucket that's in the cloud? Hybrid environments. We're starting an attack on-prem, but we're trying to get to the cloud. So how can that actually happen? If we click on that S3 bucket, what you'll notice is once we got onto Steve's computer, there was something else that we can get from him in order to pivot. One of these things that we look for, just like an attacker would, is Azure and AWS access keys. There's a higher likelihood of an attacker pivoting in your on-prem devices or landing on a laptop or a workstation where you have a developer, an IT person with these credentials than they are to compromise directly in the cloud. In this case, we found that Steve has these AWS access keys on his laptop. And what we can do with that is see where we can use it in their cloud environment. So because we have AWS also plugged in here, we can say, well, we can use Steve's access tokens to impersonate Steve in this AWS account. The other thing that we do differently than compliance-based solutions in the cloud is we're not simply reporting on permissions. So the question here is, can we get, for instance, from Steve to the actual S3 finance bucket? Steve doesn't have direct access, meaning if I was to run this in a compliance tool, I would probably not see Steve having access to the S3 bucket because he's not either in a group or has direct access to it. What we're looking for is, again, the attacker mentality. How would the attacker get there? What interconnections are configured in AWS with all these different permissions that could maybe get him there? What we did find is that when Steve is accessing AWS, he has the ability to actually manage EC2s, specifically this EC2 right here, because he has the permissions to manage via the AWS management agent. Once the attacker is able to use that and they get onto that EC2, they can also search for what roles this EC2 has. A lot of times when you have EC2s or other resources, they need to write data to somewhere. And so roles are assigned. In this case, the attacker now finds that that EC2 has a role that allows it to write to that S3 bucket and indirectly getting access to that finance data where, again, Steve doesn't have access to it, but the privilege escalation techniques in the cloud is what the attacker will be using. Okay. So this is the red team part of it, just going back to Jamie's comment in the beginning about why we are labeled a red team and blue team solution. The red team is to show you the attack paths. What would the attacker do? How would they do it? The blue team part comes into the remediation. What can I give my blue team, or if you are the red team and the blue team in this case with the automated solution, how can I fix these problems? So when we go into the campaign report, this is the blue team side of things. It's the solution. How can I defend myself against the attack that I just saw? In our core platform of methodology here, we're always focused on critical asset remediations. We don't want you to come in here and look at, I got to fix problems with all these systems. The goal is to reduce the risk to what matters to your business, right? Even if it's ransomware in this case, let's say you want to see ransomware staging, you just care about uptime of all your computers. There are scenarios you can do that as well. But in this specific case, we're focused on just these 5 assets. So what can I present my blue team to actually close them? That's what the critical asset findings will help you find. Here, the first thing we're telling you is that we use the EC2 SSM command takeover. So let's see what we can do about that. You have information about what exactly this attack is, which is, again, having the permissions to do the management. And on the bottom, you'll have some best practices, but you also have the actionable advice. This is really what you want to look at. Here, we're telling you to limit the user SSM permissions to what they really need. And you can see that we're pinpointing Steve having access to this EC2 and this EC2 with the SSM permissions. So one of the mitigations here would be, does Steve need the ability to manage EC2s, or is that a misconfiguration? If, for instance, Steve needs to have this permission, and you say, well, I can't make this change. Steve is our DevOps guy. He needs this access. Well, maybe there's another way to do this to fix that problem. As you can see here, we're presenting you another solution for that. We're saying that we also use the S3 bucket write data. On the bottom, you'll see what it says, limit role permissions on the S3 bucket. Here, the issue wasn't necessarily Steve having the access to manage EC2, but it was this role having excessive access to our finance database. Okay, so again, you have different ways to mitigate and close that attack path. It's not always one way. On the on-prem side, here you'll see local credentials. We use local credentials to pivot from Olivia's computer to Steve's computer. So what we can do as actionable advice, we have 5 different options. The first and easiest would probably be to disable that built-in administrator account on Steve's computer. In some cases, this can be used as hardening advice for an entire environment. If they have built-in admins enabled everywhere, the passwords are the same. And on the other hand, we can pinpoint and find those minute issues on systems that would allow the pivot. Even if it's 3-4 computers in some environments, that's what allows the attacker to get on a privileged device. And on the other hand, you also have the IE exploits. Here is where we had, the ability to exploit Olivia's computer because she didn't have the vulnerability patch for IE. The main use case here is when you have security teams interacting with infrastructure teams, the security team is responsible in reducing the risk, right? So you want to be able to give the infrastructure what they need to quickly close that gap. If you gave them a list of 1,000 computers with this vulnerability, that's probably not going to happen very quickly. On the other hand, if you give them a list of 10 computers that actually have a path to our customer database and you say, I don't care about everything else, please just fix these 10 computers for now, it's probably going to be a lot easier to push that out and close that risk to your customer database. So the whole point here is prioritization and efficiency. Once you're finished with this, if you want, you can also go look at all findings, which will actually show you issues on all the other devices. So again, you'll see reprioritizations here based on looking at multiple devices. Okay. The other part of the solution is vulnerability management. So we understand that customers need compliance, requirements. They want to do basic vulnerability scanning as well. So we also accompany that, but we've also incorporated the ability not to just list vulnerabilities, but also show you remediations. So what that means is if I want to look at what this vulnerability is for Adobe Acrobat, I can see how many devices have it affected, what the information about the CVE is. But when I put a checkbox here, I can also see that there's a patch that can apply to remediate this issue. So again, think about a security team doing vulnerability scanning and needing to supply this information to IT. Well, it just takes one checkbox to provide that information, right? And I can simply select that patch, put a patch request in here, say go fix this. It'll automatically populate the patch as well as the devices that are needed to have it. And just click next, select an SLA date, and review and send. So now you'll have actual patch requests here, so you can track exactly what you're asking IT to do. But again, the whole point here is to go from vulnerability to patch as quickly as possible. Again, saving on time and prioritization for your teams. And the last part here is the dashboard. The dashboard simply shows you how you're doing over time based on weeks, months. It also shows you your latest high-risk scenarios, as well as choke points. The one thing I want to just talk about briefly is choke points. The reason for that is in every environment, there are devices that cause more risk than others. And being able to find those devices will help you have a quicker impact on risk rather than, again, focusing on everything all at once. In this example here, we see that across all our scenarios, we have about 10 systems that get the most access to our critical assets. And if I wanted to reduce the risk overall in my environment, I would probably want to target, for instance, Alex. Okay, and Alex is basically compromised by this Apocalypse CVE, and in turn is compromising 37 of my critical assets. So if I go and simply patch Alex's computer, that will have a big effect in reducing the overall risk. This one is important in large organizations because with thousands of systems, again, sometimes it's easy to find those 20 or 30 that are causing the most risk and put your focus there. Okay, and that's pretty much it. Any questions?
Thank you, Gus.
No problem.
We may have muted a few people, so Lee, if we can make sure everyone is.
Oh, okay.
I don't have any Q&As to answer, but I'll answer a few of the questions that we were asked before, just to give people some of the information that we've learned or known. So there is this is a sensor-based application. It is installed on the devices that we're testing the attack paths from. There is it's priced on a per month per sensor model, and on top of that, there's a minimum of 100 sensors in your environment to get this done. I'm trying to think of the other questions that were brought to the table that were focused on usability. We had some questions around reporting and APIs. So both reporting is capable in the system, and the system's API driven. So if you want interaction with an existing ticketing system, or if you wanted to interact or pull data from this platform to a different system, or interact with another SIM tool, the product does interact with both. It can be cloud hosted or on-prem hosted, depending on your preference. And I think that about wraps up the questions we had in the previous sessions. All right, I do have a question in the Q&A. So the question is around scanning and timing. How often does he put it in terms of a full scan, but I think it's really focused around how you schedule those scenarios and how often those scenarios run.
Great question. So in this scenario screen, this is where you can see all your scenarios. Because of the way we operate, and just going back to Jamie's point that we don't cause any operational risk in the environment, the sensors are simply data collectors and nothing more. So when they're pushed out to your devices, there's no reboots or anything like that. All they're doing is looking for specific information like cache credentials, local credentials, specific configurations of the devices, as well as IP address changes and all these different components that would obviously play out in an attack. Now, because we're simply collecting information, there's no risk. We're never running live exploits where you have to say, I need to be prepared for a system crash or anything like that. So every customer runs this daily. The sensors collect information all the time. So if there's an RDP session that happens, we'll see it in the Windows event log. We see what credentials cached. We put that into play to see what can happen during the campaigns that run. But it runs every day. There's no risk or anything like that. There's no overhead on the endpoints. We're also not resource heavy. And so with the sensors, you'll see them in here. There's literally nothing that happens. And because we're not trying to stop malware, it's not like we have, disk drivers and everything else. We can wait for our information. If the system is busy, we'll wait, an hour, right? We don't need this right away to show you what happens throughout the day. We put all these pieces together continuously.
Yes, a question that just popped in that I wanted to make sure we cover before I go too far. Someone asked, how long is historical data kept?
So campaign-wise, I don't think there's a limit, but I haven't gone further than a year. But I do not believe there's a limit at the moment.
And then, Jamie, did you want to add something?
Yeah, there was another question around where is the data kept, specifically GDPR, right? If someone chooses for an on-prem implementation, does all that information stay local to the on-prem? Does it ever get pushed to a cloud without their knowledge, etc.?
Yep. No, if you do on-prem, you can run it air-gapped. It's 3 servers. One is the Nord server, which is the brains of the operation. One is a Mongo database server. Both of those run on CentOS or Red Hat, whatever you like, and one Windows server. So it could be completely air-gapped. It's your data. And from the cloud perspective, we can push out the instances to whatever region you want. So if you're in the EU or if you're in the US, we can push it out to your preference of region in AWS.
Cool. One question that came up in the previous sessions was who builds and who creates the scenarios, right? The actual exploits, right? I shouldn't say exploits, but who's creating the methods to try to hack these systems?
Yeah, so the methods are always researched. We have a dedicated research team that all they do is just find different attack techniques that are being used and then basically tell the product team, hey, I need you to put this in here and this is what you need to do. So our research team plugs all that in. This is why, again, this is a blue team tool, not a red team tool. To create scenarios, it really takes 3 clicks. I mean, you can just say here, test number 1, you quickly pick through the scope, you select a breach point like, tell me I want to start it from Alfred or Alex's computer, or maybe I want to start it from a specific subnet. This is where I want to start the attack from. You can simply select your critical asset. So you can say, try to target my domain controllers, or maybe something along the lines of, I don't know, let's say specific OU has our New York servers. Once you do that and click next here, you'll see that you set up the campaigns to run daily. It'll show you multiple attack vectors. You can also enable dynamic breach points so that the system randomizes where to start attacks from if you don't really know. And then you click next and create scenarios. So that's all it takes for anybody to start a risk scenario towards specific devices, subnets, or whatever it might be. You do not need to worry about what attacks are being used because that is plugged in and that's part of the automation part by our research team. The only thing that changes here is your environment. So if we can't get somewhere today, we might be able to get there tomorrow, again, based on what your environment looks like.
Gus, do you guys have a rollout plan or something around how often your attack methods are updated, or is it as determined or as they're developed, they're put in the software right away?
It really depends on the attack path. So the on-prem attack paths don't change often. The thing that I'll probably tell you that changes most frequently is like CVEs, right? There's like zero logon or this or that we're seeing used by attackers. So those are the things that get plugged in quickly. Now, as far as attacks, because we're always focusing on the root cause, for instance, we're not telling you that there's 40 different ways to do a privilege escalation attack and you should try to cover every single way because tomorrow there might be 41. We're focused on what happens after that privilege escalation happens. Well, they're going to try to get credentials or they're going to try to get to another system. So when we're looking at attacks from the on-prem side, we're seeing that if you cover the gaps with credentials and we're telling you where they can be harvested, then it's going to be the same all the time. Like the attacker is after the credential, not after your EDR solution. So if we're focused on where we can get credentials, how we can use them, or where the vulnerabilities lie and things like that, they don't change much because those are the tactics the attacker's after to use, and we're focused on the root cause of the problem. But again, it all depends. Like I can tell you there's a lot of focus in the cloud of things now because there's a lot of hybrid environments. I don't think there's any other solution that does what we do in the cloud as far as like with AWS and Azure and the hybrid combination, seeing how people can pivot from on-prem to the cloud and all the escalations that can happen there. So a lot of research is happening in cloud attacks because that is, where a lot of people have migrated to. So, there's a lot of effort there from our research team there.
Oh, and there was another question around maybe a hacker actually hacking your sensor. So I'll go ahead and answer that question for the crowd. So the way the sensor works is, the sensor is effectively a data collector on your environment, almost no different than any inventory software. But the sensor being local to your machine is collecting all that data, sending up that data to the computational algorithm, right? That XM Cyber is, whether that's in the cloud or on premise. And once that algorithm has run through the potential possibilities just on the data collection, then it's asking those sensors just to validate, right? For instance, can I get from point A to point B? Is there a firewall in between? Is that a real component? It's not actually performing the attack. It's just saying, if I wanted to do the attack, could I do that attack? So I think the answer to the question is, could the sensor be exploited? I think anything can be exploited, but they're not getting any data that any other of your EDR tools or your inventory tools are already present on your machine as well. So all those tools are probably targets in some scenarios, but this is the only tool that's designed to prevent that. And that is all the questions we have right now. So we're getting to the top of the hour. If there are no more questions or nothing else to cover, we can wrap this up. So we'll give another few seconds for any more questions that trickle in. All right, let's wrap it up. Thank you, Gus. I appreciate the time. And thank you, Leo.
Anytime. It was a pleasure. Thanks, everyone.
Thank you, everyone.
Bye, everybody. Have a good day.
Bye-bye.